Um, Glad to see so many here. It's great to be here in Krakow, Poland. It's an amazing venue. It's been a great con. Hopefully I'll send you home on a good note. Me, I'm a pen tester, security researcher. Occasionally do some training. Social media, you'll find me as Wireghoul, and I have a blog which I've been neglecting pretty badly for the last couple of years, but I'm going to push some additional content onto the blog after this talk because some of the concepts need a lot more in-depth discussions, so maybe worth looking at that after. All right, so it starts with sort of a story. Many years ago when I was doing a pen test of a particular CMS, they had about 7 different ways to upload files, but I couldn't upload an actual web shell and get code execution on the box, which was kind of frustrating, and I felt like it wasn't filtering sufficiently that I should be able to exploit it. But as pen tests go, you ran out of time, and then a few months later, I was sitting reading a book, and I had this idea, because the problem that I had with the CMS was it would allow you to upload files, but every file would be placed in its own directory. Even if it uploaded a zip file and extracted multiple files, they all got their own directory. And I'd been trying to use a htaccess file to say, well, any file that's in this directory that's, say, a JPEG should now be treated as a PHP file and get a web shell that way. But that didn't work because I only had one file in that directory, which was the htaccess file. And so I'm sitting there reading a book, and the idea hits me that, but what if the htaccess file could reconfigure itself to be a PHP file? And so I did some basic testing, and htaccess, or htshells as I call it, the project, was born. It's basically just a collection of Apache directives and some fun things. Some people have called it super janky web shells. It's really like not quality code at all, but you know, it works. And yeah, I had someone say it was sort of brilliantly nefarious. So I get a bit of mixed reaction. Some people think that I'm being really evil, and people think I'm being really clever. So this is kind of an old project. The code has been on GitHub for a number of years, but I'm adding a whole bunch more to it. So I'm going to be releasing it after the talk. So the basis for this is something called runtime configuration. And runtime configuration kind of dates back to the days where you sort of had shared hosting, and you couldn't like lock down a web server for just a particular website because individual websites would need different things. So, you know, your bulletin board would need something different configured to, say, WordPress. And so the trivial solution to this was to allow the users to configure their own directives, sort of. Still very much in use today. Most CMS have a htaccess file with rewrite rules. It kind of exists all over. I'll mostly be talking about Apache today, but it's not just limited to Apache. So this is kind of an order of most useful down to least useful. So the bottom two, the only directives you can really play around with in a htaccess files for those web servers is authentication, which may be useful for some attacks, but it's not a quick win on a pen test by any means. So what we're really looking to do is we're looking to alter the configuration that the web server has. And because we're able to use a htaccess file, we can alter the behavior for that particular location where the file is placed, as well as potentially subsequent directories. So, you know, a really trivial example would be to combine it with, say, insecure CSRF file upload. Somebody browses to your website, you push the file, now authentication is disabled for their admin panel. Yeah, it's handy. We'll run it through a quick sort of idea of how Apache functions and how these attacks sort of exist. So at the very basic concept level, a web server receives a request and responds with some content. That's really all there's to it. Of course, for more enterprise-ready web servers, you want to have a bit more flexibility than sort of static content. So Apache has a number of steps to sort of processing the cycle. I'm not going to go too in-depth. The Apache project has a lot of documentation on how this actually occurs, and certain web application firewalls like mod rewrite has even more information on sort of the sequence and order of operations. Oops, sorry, backwards. But essentially what happens is it receives a request, it does like negotiation, parsing, what language, what compression should I send back to the server? Are they asking for a subset of just, bytes sequence 20 to 200 of the file because it's a download resumption or something? So it does all this pre-processing, and it gets to a handler and goes, well, is it a CGI script, a PHP script, a static file? Do I need to do language translation, which Apache can do? And then it passes it to input and output filters. And then once it's eventually served the content, it logs the data. So, and it exposes hooks during each of these stages, and that's really what Apache modules rely on. So depending on what the module does, it'll hook in different sections. Not super important for what we're discussing today, but that's how it works anyway. Most of Apache's functionality comes from modules. And you can just go on the website. They have a list of all the modules. They have a list of the individual configuration options for the various modules. And they also cover this bit here, which talks about where can you use it, what are the requirements, etc. So the first thing that covers this is something called context. And that means that for certain sort of security sensitive directives, you can only use it in, say, the server config. So you can't reconfigure, say, the SSL keys that the web server is using in a per directory basis because it's sort of structurally wrong. And then sort of it goes down to the strictest, server config. You have to be root to write to the files. These things can't be overridden. And then you sort of dwindle down to htaccess, where the, I guess, least important or more directives that have a higher need to be reconfigured for various behavioral purposes. The other thing that's important is which override level you require. So again, there's a bunch of different sort of permission levels. Most of the fun attacks all depend on the options directives. So, things like mod rewrite also depends on options. It's usually enabled. So just go back to this one. I'm going to say this again probably a number of times during the the presentation. The one thing you want to do to stop any of these attacks, you set allow override none, and then nothing of this actually works because you've locked it down in permissions. So now htaccess files is generally recommended not to be enabled on production servers, and the reason why is not security, sadly, it's performance. So say you're looking for an image of this URL. The Apache web server will start at the root directory, and it'll look for a htaccess file in each of those directories. If it finds a htaccess file, it'll parse it, and then when it reaches the end, it does order of precedence operation and kind of merges it into one config and then applies that for that one directory. So it is pretty performance intensive, but you should also disable it for security reasons. So just twice as important. So now that we know what htaccess files are, what can we actually do with them? So some of the existing attacks that I did, and obviously the one that I think sees the most use, is just straight up put a htaccess file on there, get a web shell, run commands, hack the server, steal passwords, etc. But we can do a bunch of other things too. We can cause the web server to leak information. We can make the web server disclose things. So a good example might be if you're able to use, for example, mod rewrite to set certain query parameters. You can leak, say, the source code of PHP files on the server, which could be handy to find other vulnerabilities in the case that you can't get code execution. But there's a whole bunch of different attacks, and it's kind of important that you understand that the htaccess file it's not like it's something static. It's almost like a programming language. You kind of configure it to do what you want, and then it does it. So you can see here we're executing commands, and we're doing this. I'll go through this later on. Sort of the important thing here is that this one is done through rewrite. So it's not, there's a bunch of different methods to make htaccess do certain things, and there's usually more than one way to do it. So at the core, the htaccess files that I've produced are polyglots. So they're a valid htaccess file, because if you have an invalid htaccess file, Apache will refuse to serve content. So they have to be valid from Apache's parser perspective. Typically, we also make them perform an action such as being a PHP shell or a Ruby shell or a CGI shell, forget code execution. And because we like to see nicer output than this stuff here, I quite often put HTML comments in there. So if you open it in a browser as opposed to the command line, you get a nice looking interface with the input box to run the commands, etc. So, yeah, so they're polyglots, which are popular toys. All right, so how do we actually achieve command execution in say, htaccess? So access to htaccess files by default in Apache is denied. So the first thing we do is we override it, and we say for any file that starts with .ht, you know, typically that would be a deny operation, but in our case, we're reconfiguring access for this directory, so we're overriding that and saying, now you can access .ht access files. Incidentally, this will also let you access a .ht passwords file remotely if it did exist in the directory. So you can steal and offline crack passwords, possibly. The next thing we do is we want to reconfigure Apache to recognize that this particular htaccess file, it's not just a htaccess file, it's actually a Ruby file. So yeah, we define that if the module mod Ruby exists, because we don't want to use the directive if the module doesn't exist, because that will break the parser. The parser goes, I don't understand what these directives are, and then you get a 500 error. So by putting in inside an if module, it's fine. And we basically go down here and we see set handler. We're just saying when someone's accessing the .htaccess file, just run the Ruby code. And then, of course, down here we have the Ruby code. The other thing that's kind of important is up here, we disable the built-in safety in Ruby that lets us do eval, or sorry, command execution. So if you don't reconfigure Ruby as well, you wouldn't get code execution. You can still run Ruby, but you know, we want shell. So that's basically, this is it. You upload it to a directory, and then you just hit the file, and if mod Ruby is enabled, you will get shell. All right. So, like I said before, there are many ways to do this. You know, don't just like grab the htaccess file from the repo. You know, feel free to change it a bit. The order of operation doesn't really matter. So you can shift the text around, add some spaces to break the MD5 sums for, you know, dodgy indicators of compromise or whatever, or remove the comments. Just make it a bit different so it sort of looks different. So now that we know how to sort of attack a web server with a htaccess file, the biggest problem is how do you actually get the htaccess file on the file system? Because it only works if it's Apache is serving it from the local file system. So I mean, the most generic method, it just straight up form upload. You know, they'll have something like upload an image, and they'll check for you're not allowed to upload PHP files because, you know, those things are bad, but they use a blacklist and they don't put htaccess on there, and so you just pop it up and you get shell. So that's most of the, I'd say 90% of the time, that's what I do. Sorry, did I? Generic method, yeah. Some other ones that are more, I guess, sort of specific. You can select into out file from SQL injection, XXE, etc., etc. But it's not so necessarily so important how you get it there. It's just you got to try to get it there. So yeah, typically like I said, file upload. Most people don't block htaccess files, and that's all it is. XXE, very unlikely to be exploitable because of the specific conditions. You'd need typically an XML parser that supports this specific behavior in handling of jar URLs. But you can basically give, in the case of say Java, you can give it a jar URL to a zip file, do an exclamation mark and an individual file name from that zip file, and it will download the zip file, extract that one file, and keep it on the file system. And so if you use, say, chunked encoding or whatever, that'll let you temporarily place it there. Unfortunately, it usually ends up in places like temp, which aren't web accessible to begin with. So it would generally have to be something like a router or something that has kind of limited temporal read-write storage, and so it places a lot of stuff in locations where they wouldn't normally be. But it is a way to potentially do it. The biggest problems with placing a htaccess file on the server is that you only get one shot. Most of the time, they will not let you overwrite an existing file. So, you know, if you didn't do good recon and you upload a PHP shell on a server that doesn't support PHP, then you're usually out of luck. There's a couple of ways around this. One is that you can usually combine multiple languages in a file. So actually in the repo I have a file called htaccess multi-handler or something, and it does, I think, 5 different languages. So as long as any of those modules are present on the server, you upload it, you get a shell, and you don't really care where it's from, it's just executing commands. One of the other ways to do it is you can remotely fingerprint a lot of the modules, and like 10 years ago I wrote this tool here, LBmap, and it has an Apache remote fingerprint, that tool that will detect sort of which file extensions are in use or which modules are in use. So that's pretty handy to have. And test it locally before you upload it, right? Like Kali has Apache native, so just test it on your Kali instance or whatever before you put it on the server so you don't burn your access. So you'd think that with this thing being around for a number of years and sort of being, I guess, infamous for attacking web servers, there'd be some detections, right? Antivirus, that'll keep you safe for sure. It says on the PCI standard. Yeah, the first time I uploaded this was almost 2 and a bit years ago. Still 0 detections, and of course, since you can kind of modify the files however you see fit, I'm not sure if you're going to get really effective detection out of it with antivirus. So yeah, web application firewalls, maybe they can stop the actual post with the upload, but if it can't stop the post with the upload, once the file is on the file system, the web application firewall can't stop it. So yeah, it's the wrong sort of protection methodology. This thing has risen up in the past couple of years, like web shell detectors, I guess because people get hacked all the time because they don't patch their WordPress. Most of those do a really terrible job. There's a bunch of them that actually detect my files. If you call them, you know, webshell.txt, it'll find it, but it doesn't scan dot files. If it's called .htaccess, it won't detect it. So, and again, most of them will generally only look for PHP files. If you put up like a Ruby one, it just doesn't work. So, NeoPI did this statement a bunch of years ago saying that, oh yeah, we really should look at this because, you know, we've realized we would actually miss it when we're scanning. I haven't actually tested in a bunch of years. They may have added it, but again, their focus is on PHP shells. So if you just sidestep that problem, then the other thing is they generally run from like cron jobs, you know, like daily, weekly, whatever. So if you just RM the shell when you're done, yeah, they didn't find it. This thing pops up all over the place. Someone has basically tried to implement the web application firewall through mod rewrite. It's a terrible idea from performance reason, and it's also, well, basically just a terrible idea. We'll talk more about this later. And then, of course, there's this one repo on GitHub that just has my handle as the Yarra rule for detecting malware, which I think is pretty funny. But yeah. So yeah, remove my name from the web shell before you upload it, and he will never find you. Allow override none. That is what you would do as a system admin. It doesn't stop absolutely everything, but damn near everything. There's some corner cases that'll fall through, but you should always do this on your production servers. You write the config in the actual server config in the virtual host section. You don't put stuff floating around in directories because from a QA perspective, from a security perspective, from a performance perspective, they're all bad news. So just do that. Some myth busting. So I feel like a lot of people don't understand sort of the mindset behind this. And like I said again, these aren't sort of static attacks. You know, you take a htaccess file, you can modify it, and you can maybe, you know, bypass the intended controls, etc. So a common one is uploads outside of a web root is safe, right? If I can put a htaccess file outside of the web root, and then everything's fine. And that's generally true. Please do put your web or your uploads outside of the web root. But if you, say, run the images through a thumbnail converter and then have a uploads /thumbnails, and that thumbnails directory is web accessible, because as we spoke about earlier, it looks through every directory all the way down. Even if it sits outside the web root in a parent folder, the config will still apply, and so you can execute code even though the htaccess file itself isn't web accessible. Right, one of the other ones, which as I said before, this guy who like wrote a .htaccess based web application firewall to stop htaccess files, it just doesn't work, because whatever privileges or permissions that htaccess file has as a parent directory, when I'm in the more specific current directory, I should be able to override whatever it is that you're doing by reconfiguring the local permissions. And so the only place it would work is like if you have an uploads folder and you put a htaccess file in there so I can't upload one, then yeah, that'll probably block it, but it doesn't matter what the content of the htaccess file is at that point. So we'll look at this from sort of a story. I can't remember, does it have the year on there? Yeah, so 2015 February, I spotted a reference to my project from this full disclosure post. And it's a social media thing, project, and they had a insecure file upload. Same thing, they blocked like PHP or whatever, but they didn't block htaccess. And they said, the researchers who did this, they said, you know, it's fine because by default there's a .htaccess distribution file that comes with the project. But unless you like rename that to .htaccess, it doesn't take effect. And if you do rename it, it actually breaks the use of htaccess because it does a redirect match rewrite. And they actually tried to do a rewrite engine off. And that normally takes care of any sort of, you know, mod rewrite as a web application firewall protection. So you put that in your htaccess file when you upload it, and then that WAF disappears because you've disabled it. In this case, it was a little bit more specific. They were using redirect match, and sort of in the Apache internals, this doesn't map directly to a file. It just does a regex on the handler or the parser earlier in the request parsing sequence. So it never actually arrives at like a file handler, which actually stops the use of mod rewrite. So I thought, well, you know, we should have a look at this, revisit this bug. And so I grabbed HumHub, I put a .htaccess file in there, and yeah, it didn't work. I can't access .htaccess directly because the regex sees it and serves the 403 error. But what I was able to do was I could use a set handler operative. I'm going to show you the source code from this PHP or htaccess shell later. And so what I did was, instead of hitting the htaccess file directly, you see here I'm hitting an index.html, which they already had in there. And with the same query string, it causes the htaccess to say, no matter which file is being served, I'm overriding the file handler to always treat this as a PHP file. Oh, by the way, also append this additional PHP code to that PHP file, and then, yeah, we get code execution. You can actually kind of see some of the htaccess file leaking out there. So while they had a sort of a semi-efficient protection against it, if you actually apply a bit of logic and understand how Apache works, htaccess files cannot protect against htaccess files. You just walk around it. Similarly, it could enable the server status as the handler instead of PHP, and yeah, you can go on for forever. So So like I said, I released this, I think 6 to 7 years ago. And there's been a bunch of changes to Apache since then. The most notable one, which I did introduce changes for in the repo, it's like semi-up to date on GitHub, was they changed the authorization code. So the specific directives that you use on Apache 2.3 and older has like allow from all, deny from all, sort of as like the core directives. And the new one has like a require all granted. And of course, if you include that statement and you upload it to an older version of Apache, you get a directive parsing error. So you really have to like fingerprint Apache and uncomment the one line that you need. They also added like a low override list, which really lets you lock down the granularities. If you have to allow override something, say mod rewrite, you can actually say, well, we will allow override options, but you're only allowed to configure like these. However, it's like a comma-separated list, and then that way I can't just randomly do whatever I want. So that actually locks it down as well. It's a great addition. I don't know if it hasn't been attributed to me, but I'd like to take the credit for it. But the big one was we got if statements. So now we can add logic to our htaccess files. So, I mean, it's not quite Turing complete, but we can do dynamic directives. So if we put in like a lot of if statements, to do if this condition, apply these directives, in if this other condition, and if you add that to like granularly add and remove individual directives one at a time, you can build a completely different runtime execution of the htaccess file, just depending on the query string, which we kind of saw earlier. So I wrote this here. Pretty simple. This one doesn't allow you to like stack multiple ones because it checks that the whole length of query string equals. You can see my really fancy obfuscation there. It beats all the web application firewalls. But so what you could do is you could change that to be, say, a regular expression or something which would allow you to stack multiple different configuration directives in one query string. But it's really simple, and as we saw before, rather than doing add handler something for a .htaccess file, we just say for any file in this directory, as long as we trigger this query string, that's the handler it's going to use. So you don't have to hit the htaccess file directly, which is kind of handy. Of course, again, this is only valid on Apache 2.4 onwards. You upload this to an older version, you get a 500 error, and you're out of luck. So. Yeah, and as we saw, just by changing you can probably not see that at the back. Changing the query string, we get in server status. Changing the query string again, we get PHP execution. So it's really simple. So now that we've done all of this, what am I actually doing to make htaccess shells better for 2018? So for Apache, we're adding a bunch more of sort of the Apache 2.4 directive-based shells. I'm adding a new stealth shell and also doing some syntax and a couple of different module-dependent attacks which can do some really neat things with low privileges. So I've got one that will steal passwords or credit card details using only mod rewrite. So if you have nothing else available on the server, you can still do it, but you'd probably have a hard time getting the htaccess shell on the server if it can't run any scripts. So IIS, so Sharosh initially ported the notion of htaccess shells to IIS, and he wrote like an ASP classic IIS web.config version. That's really neat, but modern IIS does not support IIS classic. So I've added .NET, PHP, server-side, include ones. But getting code execution on IIS is a lot trickier because in the case of, say, a .NET, the directory you're uploading into has to be defined as an application root. In the case of PHP, you need to know where the fastCGI executable for PHP is. So hopefully you can leak the path through some sort of, feed PHP an array and it'll spit out an error that shows you what the path is. And then, of course, in the case of server-side includes, they have a set of directives to let you execute like CGI scripts or whatever that you can configure in web config. But for command execution, you actually have to set the registry value, which again, it's hard to do remotely. So here's an example of ASP.NET running. It's almost identical to the one that did ASP Classic, but yeah, we're also going to actually update it so that we don't just do hello world showing it code execution. You add actual command execution on there, so you can actually do fun stuff. PHP, and I don't know when they actually did this. They added support for a per directory config in PHP, and this works on like universally anywhere where PHP is run as like CGI, so fast CGI, PFM, etc. And it'll work on servers that don't normally support per directory config, so like ng Inc, Slide HTTPD, Heroku, if you're IIS too for that matter. So if you're running PHP as like a CGI module, you can just drop a .user.ini. So here's yet another weird file that you need to filter for your file uploads. So this one has a slight difficulty in executing. It actually requires there to be a PHP shell, or sorry, a PHP file, any PHP file in the directory where you're uploading to. It doesn't have to be yours, it just have to be an existing PHP file. Because this is based on the notion that you're just going to append this file, and then you have a comment down there that, yeah, again, just spits out PHP info. So yeah, one other thing. But as I was kind of working through some of these, I had this idea for a stealth shell. So I wrote some stealth shells with the initial htaccess project that kind of like hides from logs. But it still requires that you access the web shell sort of directly, indirectly. So it's not so great. And I kind of had this idea. Many years ago, we were sitting on a plane on the way to do a CTF in Australia. And we knew that one of the scoring points was putting your team flag as like the index page of the web server. And I'm like, well, what if we could like backdoor that, so even if somebody overwrites the index file, it'll still display our flag. So I was messing around with it, and I found a way to make htaccess files serve my content no matter what. And hopefully we could kind of sneak that file in a location where they wouldn't usually look, like the root directory or somewhere outside of webroot, and keep them confused and sort of keep our team scoring more. So I kind of had this idea, and we prepend a PHP script and then just print our flag, and we exit, and we don't care about any other sort of execution. That's fine, but it's not really a web shell. So a bit later, well, what if we change the post or the pre-execution to a post-execution? That all worked fine, but I noticed when I was sort of accessing the website in the browser would sit there and spin, like waiting for data from, demosite.com, which was kind of not great. So what we ended up doing is kind of thought about how does the browser process the data that it gets. And it's really simple. If you send a specific content length, and then the content that you send matches exactly that length, the browser goes, okay, well, I have all the data that I want, and it closes connection and goes away. It doesn't care whether or not the web server didn't close it. So that was pretty simple. We added some oh, sorry, I should skip that. So the other thing is, when you're doing this, you can't read and write, like sort of interact directly with the web shell, so you have to go out of band for the command and control. So what we're doing here is, first we're saying that we want to append htaccess whenever this thing is running. We enable output buffering, and that's very important because we want to see what Apache is already ready to send, and we want to stop it at the point where sort of our content start. And we do that down here. The first thing we do is we call go, which is function go down here, and then it basically it gets the content that's sitting in the buffer, and then clears the actual output, and then it finds, because the problem is that one character there gets appended. So we got to find that and clean that out, because we don't want to show up in somebody's output. Then we set the header for content length, we set that, we flush the buffer, and the browser goes away. But we're still sitting here in execution. So once the function go has finished, it gets done here, and then we just read remote code. We do a function callback rather than say an eval, because this is less likely to get blocked in PHP hardening or whatever. And then we just call that function, and that's it. So this allows you to put this on the server. Any normal request that comes into a PHP file on that server will execute this in the background after it's served the content to the user. The user can't see it, and it just reads the content from there. So it doesn't get logged. And again, before we exit, we clean all the content. So there's no additional output that's being added to there. So the logs look perfectly normal. The traffic is coming from just normal users. You know, there's nothing. So unless you're doing on the server side, you're doing connection tracking, right? You won't see that one there, and everything's fine. So we're going to run a demo of this. This is sort of audience participation. I can do it myself if you don't trust me. So I've got a demo site here at Nazdarovia, justnotthehacker.com. And if you guys want to get ready your phones, whatever, we'll do a bit of an experiment. And I got with me some koala bears. So sorry, they're not actually bears. You're not allowed to say koala bears. They don't have the correct qualifications. So if somebody wants to have a chance in a koala, then let's do this. So. All right, and the way this works is I've just got a command file here. You guys hit that site, and then as soon as I'm done, I'll just type in the command to run. If somebody would like to refresh that, we should, yeah, it ran. And it's asynchronous, so I'll put this in, and then, yay, somebody ran it. Nobody's putting anything in the query string. What's wrong with you? So, yeah, it just either that or I'm not logging. So yeah, so we can just run one more, and if nobody, somebody, no, that's not going to work because you're not hitting my htaccess file. Good try. Now this is a very specific. It's pure CNC. So all right. I'll just I'll throw these around, or you guys can come up and get them at the end. All right. So we've seen that this work. It runs out of, like, you can't see the website loading any different, and it just pulls the commands.txt, and the commands.txt it's actually wrapped in a PHP script. But I'm not going to release sort of the CNC part of this because I'd rather not be responsible for creating like script kiddie web server botnets. So you're going to have to do your own code if you plan to do that. All right, so conclusion. Disable this thing if possible, like I said. Allow override none. Right? It stops it. Of course, the .userini in PHP and the web.config is slightly different. You have to do other things with those. But I'm kind of hoping that this will like die off pretty quickly, because luckily the advent of DevOps and cloud, it means that people are using load balancers and Elastic and containers, and when you're only serving one web site or one web function, one API, whatever it is that you have, you can afford to hard code that config completely, and you can lock it down. You can harden the PHP, you can harden the Apache config, and then this will never happen to you. So that's it. Any questions? Yeah, got one at the back. Did you have one? No? Yeah, okay. So in the stealth shell, the question was, in the stealth shell I had, I'll just pull it up. I had some junk Apache directives. And where is this? Yeah, if module lol1. So the reason why we're doing that is it tells Apache, like, don't worry about the content inside here unless this module exists. And of course, we pick the module that doesn't exist. And then we add this one here to say, because it still does some weird parsing. So by adding that one, we nest out of the Apache parsing. And it allows us to write PHP in like a nicely formatted PHP. Otherwise, you'd have to have it all on one line. I mean, that still works, but this is a bit more maintainable. So the only reason it's there is just for my own sanity. All right. Any other questions? No? All right. Thank you for your time. And yeah, come up and see me if you want a koala.